In this video, we're going to be talking about factors and GCF. By the end of this lesson, you should be able to prime factor integers and monomials, and then you should also be able to find the greatest common factor between numbers and monomials. Factors are the quantities that are being multiplied together to give you a number. When we look at numbers, we identify numbers as either being prime or composite. Prime numbers are numbers that only have two factors, so 1 and itself. For example, 7 would be a prime number because the only numbers that multiply to give you 7 are 1 and 7. Versus composite numbers, which have more than two factors. So they have multiple factors, such as 6. 6 has 1 times 6, 2 times 3. So it's got 4 factors versus 2. When we look at factoring, we're going to look at factoring a couple different ways. We're going to first start by factoring a monomial. So the factored form of a monomial would be writing it in expanded form. And to write it in expanded form, you're going to do two things. You're going to break up your coefficient into the product of its prime numbers. And then you're going to expand, you're going to write the variables with the exponents in expanded form. So if we have x squared, you would write it instead of as x squared, you would write it as x times x. The variables cannot have an exponent on it when you're writing it in expanded form. So you are breaking up your monomial into its smallest pieces. When we're identifying the greatest common factor, this is going to be the largest factor that two numbers have in common. So if we were looking at the numbers 18 and 24, we would list out the factors of 18. So this would be 1, 2, 3, 6, 9, and 18. We look at the factors of 24, so that's 1 and 24, 2 and 12, 3 and 8, 4 and 6. And then we look at all of the factors that they have in common. So we know that they both share 1, and they both share 2, they both have the factor of 3. Only one has a factor of 4, so that's not common. They both have the factor of 6. And so we see that they have 4 common factors, the greatest of which is 6. So when we're looking at greatest common factor, you're looking at the largest factor that two numbers have in common. We call numbers relatively prime when the greatest common factor between them is 1. This means the largest factor that can be pulled out, the largest factor that they have in common is 1. Alright, we're going to find the factors of each of the numbers, and then we're going to list it as either being prime or composite. Now, when we're listing the factors of a number, I like to go from the outside and work my way into the middle. So if I'm listing out the factors of 8, I would get 1 and 8, and then 2 and 4, and then 3 doesn't go into 8, so this tells me, hey, I have all of my factors because once I get past 3, I'm starting to repeat digits. So my factors for 8 are 1, 2, 4, and 8. And so because my factors are 1, 2, 4, and 8, and I have 4 of them, that tells me that this number is composite. So we have a composite number. When we look at the factors of 13, factors of 13 are 1 and 13. 2 doesn't go into 13, 3 doesn't go into 13. The only factors of 13 are 1 and 13. And so we would call 13 a prime number because it only has two factors, 1 in itself. When we look at 51, again, we're looking at the factors of 51. We see that we have 1 and 51. We know 2 doesn't go into 51 because 2 is even, or 2, in order for a number to be divisible by 2, it has to be even. So then we need to see, is it divisible by 3? Well, if we have a little rule for 3, if the sum of the digits is divisible by 6, then or divisible by 3, then that number is also going to be divisible by 3. So if I add 5 and 1, 5 plus 1 is 6. Because 6 is divisible by 3, 51 will also be divisible by 3. So I know that I have 3 and the number that multiplies to 3 to give us 51 is 17. Again, we could check for 4. We could check for 5. We know 5 doesn't go in there because it doesn't end in a 0 or a 5. 6 doesn't go in there because our divisibility rule for 6 is that it has to be divisible by both 2 and 3. And if we continue this process, we'll see that there are only 4 factors for 51. That would be 1, 3, 17, and 51. So this number is composite. When you are identifying the factors, it is important that you check each and every number, even if you think that it may not be divisible. Again, a quick way to quickly check is to memorize your divisibility rules. There are rules or tricks that help you with figuring out if numbers are divisible by numbers 1 through 12. So I would check those. Again, it will be a helpful tool for you. All right, we want to find the prime factorization for each integer. So we have a couple ways that we can do this. We could break it up into a factor tree. So if I'm doing 90 and I want to find the prime factors, I could break 90 up into 9 and 10. Because 9 and 10 are not prime numbers, I need to break up both of those. 9 can be broken up into 3 and 3. 10 can be broken up into 2 and 5. And so I have my prime factors here. 3, 3, 2, and 5. And so when we're writing out the prime factorization for this number, it would be 2 times 3 times 3 times 5. Now, we do the same thing for 39. Now for 39, I don't necessarily need a factor tree for this one. I could break it up into a factor tree, but another method that we could do here is called the ladder method. So I could put 39 inside. Okay, I look for a prime number that goes into 39. So I know 3 goes into 39. 3 times 13 gives us 39. So whatever we're dividing 39 by the number on the outside, and we're writing it here. All right? And 13 is the only factor of 13. And so we have our factors of 39 as being 3 times 13. Yet another method that we could use is just to line it out. So for negative 30, because it's a negative number, I'm going to add negative 1 to my list of prime factors, and then I'm going to factor 30. Okay, well 30 is not prime, but 30 can be broken up into 3 and 10. 10 is not prime, so 10 can be broken up into 2. Broken up into 2 and 5. Bring down the stuff that I didn't change. And so my prime factors for this one, if I write them in order, would be negative 1 times 2 times 3 times 5. When we're listing out the prime factorization, it's important to list them as a multiplication statement, so that you know that those numbers multiply to give you what you started off with, your product. We want to factor each of the monomials completely. So if I'm factoring the monomials completely, remember that we are writing it in expanded form. So that means that we need to break up the coefficient into its prime factors. So 4 would break up into 2 times 2. We write the exponent and the power in expanded form. So this would be times p times p. So this would be the expanded form of our monomial. When we look at 51b cubed c squared, we're doing the same thing. We're going to break up 51 into its prime factors, which would be 3 and 17. And then b cubed is b times b times b, and c squared is just times c times c. Again, when we're factoring a monomial, which is one term, you're writing it in expanded form. So that means prime factor the coefficient, write the exponents, the variables in expanded form. If we're looking for the GCF between a set of monomials, you're looking for the largest, you're going to look for the greatest common factor amongst the coefficients first, and then you're going to look for the greatest common factor amongst the variables. So we have a couple ways that you can do this. First way that you can do this is to look at, again, 4 and 8 and say, hey, what's the largest number that goes into both 4 and 8? Okay, well, we know that the greatest common factor between 4 and 8 is 4. We're not sure what the greatest common factor is, so then you just need to list them out. Then we go out and we look at the greatest common factor amongst the variables. So I have a squared, I have a cubed. Here we have 2 a's, and here we have 3. So both of them have at least 2 of them, so the greatest common factor would be a squared. We do the same thing for b cubed and b squared. This one has 3 b's, this one has 2. So at a minimum, both of them have 2. And so our GCF, our greatest common factor here, would be 4a squared b squared. We look at b and we're doing the same thing. So for b, again, I'm going to look at the greatest common factor between 12 and 9, which would be 3. Look at the greatest common factor between a squared and a squared, which would be a squared. B and b squared, because this one has 1b, this one has 2, they both at least have 1. And this term doesn't have a c, so the greatest common factor would not contain the c term. So your greatest common factor for this one would be 3a squared b. This is how we factor monomials and how we identify the greatest common factor between two terms.